So, young man, can you tell me your name?
Right. My name is Ebubechi Kenneth Elijah.
Okay. Ebubechi Kenneth Elijah. I spotted you designing or building these things, very much busy. I was wondering what is it building? So, I would like to know what you are building because I can see um, batteries, wire, and some other electrical parts. So, tell me in brief what you are building.
Okay, alright. These are the solar inverter components.
Okay.
The solar inverter components. Now, the inverter is used to charge the battery of a solar system.
Okay.
They used to charge the battery. So, firstly, I'll start from this. This is the.
What is this?
This is a transformer.
A transformer.
Yes, is a transformer.
Okay.
They can transform from either AC current to DC current,
Okay.
depending on how you use them. It can be step up transformer or step down transformer.
Okay.
Now, is a power supply unit. Now,
Okay.
this is the diode.
Okay.
These two are the
Okay.
diode. This is the capacitor.
Okay.
C1. This is the regulator.
Okay.
Then this is also a capacitor, the smaller one.
Okay.
This is the LED light,
Okay.
and this is a resistor.
Okay.
Now, these components here now they convert AC current
Okay.
to DC current.
All right.
That is, from AC current has a waveform, and DC current also has a waveform. Now, due to this waveform,
Okay.
this capacitor has to be introduced
Okay.
in order to filter this waveform.
All right.
Now, as the first capacitor is introduced, as the bigger one is introduced,
Okay.
it filters the waveform. Now, when it filters it, now the waveform is not all that straight.
Okay.
That is direct current. The waveform of a direct current is just a straight line,
Okay.
and the waveform of an AC current is
Okay.
in a
hyperbolic.
hyperbolic
Okay.
waveform.
Okay.
Now, this first capacitor, now that filters the wave in order to make it to be in a straight form,
Okay.
to be in an AC form.
Okay.
Now, after filtering it, there is still there is still a smaller waveform that is not all that straight.
Okay.
Now, in order to make it more straight,
Straight.
now you have to introduce another smaller capacitor.
Okay. Okay.
Now, introducing it now will give you a more clearer
Okay.
straight wave of DC current
Okay.
flowing to the LED light.
Okay.
And this is the resistor
Okay.
to resist any any current. If the current is high, it reduces the current. That is building a little wedge
Okay.
to the light.
Okay.
So I don't know whether we should test it.
Okay. Just test. Let me see. Just test.
Okay.
Continue.
The light coming from your house is the AC current,
Okay,
and
okay.
this is a form of DC current. Now,
Okay. Go ahead.
okay. Now, this transformer is a 12-volt transformer. So it will transfer the AC current coming out from this,
Okay.
converting it to a 12-volt
Okay.
DC current.
Okay.
Now, let's just
Okay. Go ahead.
Alright.
Make sure you don't touch.
Okay, now it's on.
Okay.
This is
Be careful.
the DC current.
Okay.
And if we are with a voltmeter, we measure this.
Okay.
When we measure it, we get a 12 volts.
Okay.
12 volt voltage.
Okay.
That is the current coming from this transformer.
Okay. Why are you touching it? All right.
It is not something that can shock you.
Okay.
So according to it, now it's being soldered.
All right.
These are the connections, the soldering, the positive and the negative,
Okay.
the ground and
Okay.
the VCC current.
So the capacitors has actually filtered the current now.
Yes, making it
The AC now,
yes,
making it to be
the
in a straight
DC
form.
straight
Lighting.
away from.
Okay. Thank you. You can disconnect it.
All right.
All right. Having seen that and it actually worked. So what about this board and the
Right.
components therein?
This is the component of a streetlight solar panel.
Okay.
Now, this component is to just make sure that when it's when it is dark,
Okay.
the light of the solar panel
Okay.
of the solar
Okay.
bulb will come on,
Okay.
and when in the daytime
Okay.
it will go off.
Okay.
Now, this is possible through the help of this light.
It will go off so that it will enable the battery charge
Again.
Okay.
Now, this is the sensor. It's a light sensor. This
Okay.
is an LDR.
What is the duty of the light sensor?
The light sensor is what senses the light.
Okay.
It senses the light coming from the sunlight
From
during
the sun.
Okay. During the day.
Okay. That is what gives signal to the board that light is on.
Yes.
So go off.
Yes.
And when it is dark, light is off. Please come on.
Yes.
Okay.
Yes. Now, this light sensor, this is a relay.
Okay.
It's called a relay.
All right.
It gives signal to the relay.
Okay.
Then, while giving signal to the relay makes some changes.
Okay.
That is, it has some changes, some noise inside.
Okay.
That is switching over.
All right.
You can also use this relay in an inverter when you want to charge. Okay, inside the inverter, when there is NEPA, it will switch over to NEPA to charge your battery. Okay. And when there is no NEPA, it will still change over to your inverter to charge your battery. Okay. Now, for this case, now this is for the street. Is a component for a street light. Okay. Now, this is a resistor, the diode, and this here is an IC. Okay. It's an IC LM324 IC. Okay. And this is this thing. This one is a diode. Okay. A diode, and this is a transistor. Okay. LM547. All right. Okay. Right now, it has been connected like with soldering and all that. It's okay. Now, this is just to test it in order to see the sound. Okay. The sound of the relay. All right. To see the sound of the relay. That's it, the switching. Okay. When it gets the light sensor. This is it. As you can see, it's making a noise.
Okay. The relay is making noise.
Yes.
When
that is switching.
Okay. When it wants to switch. Yes. When there is light. All right. When there is sun, actually.
Yes. Okay. So this is it. Actually, I'm supposed to add a LED light here.
Okay, you are still building now. You are still building.
Yes.
Okay.
So when the light comes closer to this, the LED light will come on.
Oh, come on. Off. Okay.
Yes. So this is what I've established.
Okay. This one. And this one,
yes, they are all the same.
They're all the same.
They are all the same.
Okay. They are all the same. Now, tell me, you are still building this. I can see. Yes. Okay, tell me about this in brief.
This is another component.
Okay.
In an inverter.
All right.
Now, it's used to detect when a battery is low. Okay. This is a buzzer. Okay. It's the buzzer that detects that. It gives you an alarm of when the battery is low. Okay. Then this is a shutdown circuit. Okay. It's connected to the oscillatory circuit of the inverter. Okay. So that the inverter will turn off by itself. Okay. Well, if actually the battery was low or is low when the it turns the inverter off. Okay. If you are not around when the battery is low, in order to save the life cycle of the battery.
All right.
Now, this is just to test the sound of the buzzer.
the sound indicates that the battery is low.
Yes, that
Okay.
shows that the battery is low.
Okay, that's very good.
As is
Wow.
this battery is 9 volts.
Okay.
The battery is 9 volts.
Okay.
And it's supposed to be 12 volts.
Okay.
Fully charged is 12 volts.
All right.
As we can power it with a 12 volt light.
Okay.
Now because of the battery is 9 volts,
Okay.
that is why it can make an alarm.
Okay.
That is indicating that
The battery is not enough.
Yes, it's not
But
enough.
if the battery is enough,
Yes,
it will not make that sound.
Not make the sound.
Okay.
Now,
Good.
so
It's
this
a good
is
indicator. Thank you. Okay, let's move to this one.
Okay.
Tell me about this.
Actually, this is the first system.
Okay.
That's the other one is the battery detector and the shutdown circuit.
Okay.
Now it's connected to the electric circuit in the inverter.
Okay.
It is connected to the pin 10 of the electric circuit.
Okay.
The electric circuit, this is electric circuit A7K LME4.
Okay.
There's SG3524.
Okay.
That's it. Okay, SG3524.
Okay.
So, and when it's connected to this, to pin 10, now is this the inverter is what gives current to the battery, to the low battery detector.
Okay.
It gives current to the low battery detector.
Okay.
The low battery detector now detects that the battery is low.
Okay.
That's current coming from the battery will go over to this place, the pin 10.
Okay.
Now it will be transferred to this side.
All right.
This wire.
Okay, through this cable.
Yes.
Okay. Where will you connect this cable now?
This cable will be connected to this pin 10 here.
Okay. Okay.
And we'll solder it at the back.
Okay. It's okay. All right.
Now it will give the low battery detector circuit the charge.
Discharge.
That's it.
Okay.
They are all components.
There are components you
in
are
an
still,
inverter.
An inverter you are still building.
I'm still building. I'm not completed.
So when you complete your building or complete building this stuff, it will actually work.
Yes.
That's very good.
Different components that make up a system.
Of an inverter. So after this, within a short time, you can be able to produce electricity through solar, through light.
By God's grace.
That's very good of you. Are you a university graduate?
Actually no.
Okay.
I'm a school dropout. That's from
you just finished secondary school.
Yes.
Okay. What year?
Enter university.
Okay, you just finished secondary school.
Yes, actually I'm writing jam this year.
All right. Okay. Thank you very much. This is Ebubechi Elijah Kenneth, a very young secondary school leaver. He decided to start building products, solar electricity panels, and its components, the inverters, so that he'll be able to produce or provide electricity to solve problem of electricity and also to create job in the future. He will actually need support of well-meaning Nigerians. Thank you for your job. The society will be proud of you.